Hello everyone. Now let's discuss sample kurtosis. The formula for sample kurtosis is given by okay. So this is sample kurtosis and this is normally indicated by G2, which is n into n plus 1 divided by n minus 1 into n minus 2. So n upon n minus 1 into n minus 2, this part was there even in case of sample skewness, right? So additionally, you have n plus 1, and here you have in the denominator, you have n minus 3. Okay, so this part is extra, and summation I goes from 1 to n, xi minus x bar upon s raised to power 4. In case of skewness, it was power 3. In case of kurtosis, it is power 4. Okay. Now, in case of sample kurtosis, or in case of kurtosis, we calculate another quantity which is called as sample excess kurtosis. Why do we calculate this? This is because there is some value for kurtosis which is considered like to be the kurtosis value of the normal distribution. So unlike skewness, in case of skewness, normal distribution has zero skewness. But in case of kurtosis, normal distribution has a certain non-zero skewness. In case of kurtosis, the normal distribution has a certain non-zero kurtosis. Okay, so which is considered as a reference point of a symmetric distribution. Okay, and excess kurtosis can either be excess on the positive side or it can be excess on the negative side. Okay, so we'll understand its meaning and interpretation in a short while. But how do we calculate this excess kurtosis, which will indicate by K, let's say? So this part remains the same. Basically, you can say that it is K is equal to G2 minus thrice n minus 1 square divided by n minus 2 into n minus 3. Okay. And now, again, when we go for the case of the population, we can again apply the same approximation that we had applied earlier. And in addition to saying that n is approximately equal to n minus 1 and n minus 2, when n is large for the population, we can also say that we can also apply the approximation that n plus 1 is approximately equal to n, which is approximately equal to n minus 3. Okay. So in that case, how will these all the formulae get simplified or, will change in case of population? So for population, we'll simply have n into n upon n into n into n, that is 1 upon n over here, and this will be n square upon n into n. So this will cancel each other out. This will be 1. Okay. So in case of population, okay, so your population kurtosis, okay, so this will be equal to 1 upon n summation I goes from 1 to n, where n is the size of the population this time. Xi, instead of x bar, you'll have mu because we're talking about the population, and instead of s, you'll have sigma raised to the power 4. Okay, and excess kurtosis, okay, population excess kurtosis will simply be population kurtosis minus 3. Okay, and you can say that normal distribution has a kurtosis of 3. Now, when we consider skewness, we consider the spread. How are the tails? Are both the is one tail spread longer than the other tail, etc. In case of kurtosis, we can say that we can interpret it in two ways. We can either say that we are looking how tall is the peak of the distribution, or we can say that how fat are the tails of the distribution. Okay. So again, we'll see a solved example on sample kurtosis, and then we'll again go through the interpretation part.